Okay, let's start. So far you were dealing with the third layer of the internet model called the network layer. You have seen what are the various functions of network layer. You have got various functions in the network layer. Out of that, the one we have studied so far is the addressing function. Now I have told addressing, if you want, what is the importance of addressing? If you want to identify a device in the internet, you need an addressing scheme. So that is called it as IP addressing or logical addressing, and that version is called it as IPv4. Okay. And also you have studied about the two type of addressing mechanism. One is classful addressing and the other one is the classless, which you are going to study today. So classful addressing, you have got how many classes in classful addressing? How many classes you have got in classful addressing?
5.
5. You have class A, B, C, D, and E. Okay, and you have also seen that this IP address, it can be denoted in two ways. One is the binary notation and the other one is the dotted decimal notation. So, and the total number of addresses possible in this IPv4 is 2 power 32 addresses. And you have also seen what is the concept of net ID and host ID. And you have also seen what is the importance of blocks. In all these classes A, B, C, you have got fixed size blocks, and each block will be having of fixed size. Okay. And also you have seen what is network address. Now, what are the, so if, usually when we consider the IP address, you will have two levels of hierarchy. And if the subnetting concept comes into picture, you will have 3 levels of hierarchy. So if you want to reach a particular host, if subnetting process is involved in that, first what is the thing is, you have to reach the site, then you have to reach the sub network, and then you have to reach the host. And you have also seen what is the importance of masking in the last class. Okay. Now today you will be learning about what is classless addressing. I have pointed out what are the two problems associated with classful addressing. What were the two problems? When we were considering class C addresses, is that address sufficient for an organization? You were provided with only 256 addresses, right? So that was not satisfying the needs of a particular organization. And if you are considering class A addresses, and they were provided with more number of addresses, that is almost about 16 million addresses was possible. So in class C, the address was not sufficient, but in class A, the address was wasted. Okay, so there was some problem in classful addressing. So we will go on to classless addressing. The meaning is what happens if a business organization, if it requires only 16 address or 32 address. In our household case, if we require only 2 addresses. So if more number of addresses are provided for us, it will be wasted. So in 1990s, this internet service providers become famous. Okay. So internet service providers are nothing but they are the organizations that provides the internet access for individuals as well as for small business organization. So they have announced a new architecture called the classless addressing. I told classful addressing is obsolete now. So now we are in the classless addressing mode. So the addresses are provided by the internet service provider. Okay, so the meaning is IP addresses, they are replaced by CIDR. CIDR means classless inter-domain routing. CIDR, classless inter-domain routing. Now, what was the concept of this classless addressing? So there, when we studied classful addressing, I have told you have got fixed size of blocks, right? So in class A, how many blocks were there? Atulya? Oh, you were absent, I think. Okay, Afla, how many classes were there in, how many blocks were there in class A addresses?
128.
Yeah, 128 blocks were there. That means 128 organizations can be assigned with this class A addresses, and the total number of addresses that was provided is about 16 million addresses. Okay, so there everything was fixed. But when we consider the classless addressing scheme, you have got variable length blocks. That means they are not belonging to any class. So as an example, if I require only 2 addresses, I am provided with 2 addresses. If some small business organization, if they require 16 addresses, they are provided with 16 addresses or 128 addresses like that. The meaning is I told you have 32 bits in the IP address, so that total number of address space is nothing but 2 power 32. Okay, so the meaning is the whole address space, it is being divided into blocks of different sizes. The whole address space is divided into blocks of different sizes. So if an organization needs a particular block, these many addresses, if it needs that much addresses is provided to an organization for its use. Okay, but the condition was the number of addresses should be the powers of 2. You are not able to provide 3 address or 5 address like that. It should be in powers of 2, like 2, 4, 8, 16, like that. Okay, so a household may be given a block of 2 address. A small business organization, they may given 16 address or 128 address. And if it is little more that, they will be provided with 1024 address like that. So classless addressing means you have variable length block. When you're comparing classful and classless, there you are having fixed blocks. So many of the addresses were wasted, or also it was not satisfying the needs of the organization. So that all the things were overcome in classless addressing. So you have got a variable length block divisions in this classless addressing. Okay, now if an organization is given a block, now what it is being given is they will be providing the first address and the mask. I have already told what is the importance of mask in the last class. Mask is its important is if you want to identify the net ID and the host ID, you require that mask. So in classless addressing, if an organization is given a block, it is given the first address and the mask. I will tell you what is first address now. So that 2 pieces was more than enough to identify how many addresses were provided for a particular organization. So if I want a particular IP address, I will be provided with the first address and the mask. So with the help of that, I will be able to identify how many addresses are provided for. Okay, now coming to the slides. So what I told is classful addressing is obsolete now and it is replaced with classless addressing. Right? Now this is just an example. A block of 16 addresses is granted to a small organization. So you will be provided a block of address. It is nothing but 16 addresses if an organization requests, and that is provided by the internet service providers. And here you will have the first address, last address, etc. Now I will tell how you will be able to identify the first address, last address, etc. Now, usually this IPv4 addressing is, that block of address, it is defined in this form, like x.y.z.t/n. So in that /n, it defines the mask part. And x.y.z.t, it is nothing but it defines the IP address. Okay, so in classless addressing, the addressing format is x.y.z.t/n, where /n is nothing but the mask value. Okay, now, last class I have told what is the importance of subnetting in classful addressing. So similar to classful addressing, the subnetting concept you can use in classless addressing also. So the meaning is, if an organization is provided with a block of address, what they will do is they can create their subnets to meet their needs. Okay, so that subnetting process can also be done in classless addressing if based on the requirement of the organization. Okay, so I have told what is the importance of classless addressing. Classless addressing, you are having variable length block. So it is not compulsory that, you will be provided, the fixed size blocks, that concept is completely eliminated in this. So if a particular small business, if they need only 16 address, they are provided with that address. In household thing, if they are provided with 2 address, that is provided. So all these are provided by the internet service providers. Okay, and generally you will be provided with the first address and the mask. Now, how will you able to identify the first address in a block in classless addressing? So the first address in the block can be found by setting the rightmost 32 minus n bit to zeros. You want to identify the first address. If you want to identify it, what you will be doing is you have to set the rightmost 32 minus n bits to zeros. As an example, suppose a block of address, suppose an organization is granted with a block of addresses. Out of that, if one address, if I know that, how will I identify the first address in the block? Now look onto it. One address is 205.16.37.39. And the mask value, what it is, /n, means slash notation, what it is denoted is the mask value, that is 28 is given for you. Now, how will you identify the first address in the block is, what you have to do in the first step is, you have to identify the binary equivalent of that decimal notation. Understanding, you have to identify what is the binary representation. So once I identify the binary notation, what I will do is I will find out what is 32 minus 28. Why I have taken 28 is the mask value. So 32 is the total number of bits. So the value 32 minus 28, I will be getting some value. So what it means is I have to make that many rightmost bit to 0. So in this example, you are having 205.16.37.39. I have represented the binary equivalent of that. And if I'm doing 32 minus 28, I am getting it as 4. So what is the meaning is the rightmost bit, that 111 is being changing to 000. Okay, so all the other bit equivalent, it is remaining the same. The rightmost 4 bits, it is equivalent to 0. Okay, so the corresponding decimal equivalent is 205.16.37.32. So this is how I am able to find out the first address if some address is given for me. I require only the mask value. Okay, and I will be able to find out the first address. Understood? How will you able to identify the first address in a block? Yes or no? How will you identify the first address in a block? Yes or no? Yes. Okay. Now, moving on, how will you find the last address in the blocks? The last address in the blocks can be found by setting the rightmost 32n minus n bits to 1s. Okay, so the rightmost 32 minus n bits, I have to change it to 1s. So considering the same example, what I have just shown, so making use of that, what I am doing is I am just finding the binary representation of the given address. So I have found out. Now I found out what is 32 minus 28. The answer is 4. And what I will do is the last bit I will be changing to 1. Last 4 bits I am changing to 1. Right? So you will be getting the corresponding binary equivalent as well as the decimal equivalent. So that is how the first address and the last address is being finding out. Right? Now, how will you find the total number of addresses in the block? I'm having first address, I'm having last address, you will be able to identify now how many total addresses is given. That is depending upon the formula 2 power 32 minus n. Okay, so in this previous example, again, if I want to find out the total number of addresses, it is 2 power 32 minus 28, that is nothing but 2 power 4, that is nothing but 16 addresses are provided. So the organization is provided with 16 addresses. Okay, so now, what is the importance of first address actually? I have told in classful addressing, the first address will be always the network address, right? So if a router wants to deliver a packet to a corresponding host, what it will do is the main router, it will identify what is the network address. So it will first reach the network only, making use of the network address. Then only it will identify whether it is subnetted or not and route the packets. So the first address always in the block is not assigned to any device. It is not connected. I mean, it is not given to any of the hosts. It identifies the network address. So in classless also, the first address in the block is normally assigned to any device. It is used as the network address. And that network address, through that network address, that whole network is identified outside the world. Okay, so that represents the organization to the rest of the world. Okay, so what I told is about the classless addressing. So classless addressing, when you are comparing with classful addressing, it is of variable length block. The meaning is it is not belonging to any class like class A, class B, class C. So whatever how addresses I need, I am provided with that, but it should be in powers of 2. So if an organization requires an address, they will be provided with a block of address. Okay, so now you will be provided with the mask also, and with that you will be able to identify the first address, last address, and the total number of addresses. Right? Now when you're considering the classful addressing routing table, I have just shown in this slide. When you are considering the classful addressing routing table, I told you want to identify the network address first. So if a packet is arriving at the router, what it will do is it will first apply the mask to the destination address. Usually 4 columns are provided in each router in classful addressing. You will be having the mask, you will have the destination address, you will have the next hop address, and you will have the interface. Okay, so this I want to compare classful and classless address routing table. For that I have just taken it. So considering a classful addressing routing table, here you have 4 columns, that is minimum of 4 columns, that defines the mask, that defines the destination address, that defines the next hop address, and the interface. Okay, so when a packet arrives to the main router, what it will do is the router applies the mask to the destination address. Now, what is the importance of that? They want to identify to which network the host is connected. Okay, now if that address is found, it is sent out from the corresponding interface. The packet is sent out from the corresponding interface. Okay, now suppose if the destination is not found in that packet, if not found in that table. Now what it will be done is the packet will be delivered to the default router. A default router will be there, so that the packet will be delivered to that router. So what I meant to say is the classful addressing, the minimum 4 columns are required in a routing table. I told in the previous classes, whenever you are considering a router, you will have some data in it. So that is in the form of a table, that is called it as the routing table, and you have got specific columns specifying the mask value, hop address, destination address, etc. So in classful addressing, if a packet arrives, it will apply the mask to find out what is the network address, and based on that, the packet is delivered to the respective host. Okay, now also in classful addressing, there is only one entry in the routing table for each site. I have told routing means first you have to define this, you have to reach the site, then you have, if any subnetwork is there, you have to reach that subnetwork and then to the host. So there is only one entry in the routing table for each site when you are looking from outside the organization. Okay, so that entry is nothing but it defines the site address. I have shown many examples in the previous classes. The main router, it will, first it will identify the network address and reach there. Okay, so that defines the site. Network address is nothing but to which site that each host belongs. Okay, now when the packet arrives at the router, it checks the corresponding entry and forward the packet. Okay, so that is happening in case of classful addressing. But what about in classless addressing? So you are not, you cannot be confident enough that it is fixed. So the routing table configuration or the entries can either increase or decrease in classless addressing. So when we use classless addressing, the number of entries in the routing table increases or decreases. Okay, so it depends upon the block of address that is assigned to it, and you are comparing with the classful addressing. Okay, so this is the concept of that routing table in classless addressing. Now, classless addressing, the whole idea, what all I told, it is based upon CIDR notation. CIDR means classless inter-domain routing. Okay, so I told the importance of classless addressing is it is reducing or it makes less severe the depletion of addresses. Each organization is provided with a block of address. So the IP assignments, they are not limited to the three classes what I have specified, that is class A, class B or class C. It is not at all limited to the three classes. So if any IP address with the first octet, if it is varying from 0 to 223, it can be allocated to any size block. So any block can have the address. It is not fixed that 0 to this much will be used in classless address. It is not that the first octet, if it is varying from 0 to 223, that address can be given to any size block. Okay, so in order to do that, the CIDR notation was used. Slash notation was adopted. So if I need 500 addresses, what will be the mask value I get? I will be provided with mask. I have told if I need, if I'm going with classless addressing, the internet service provider, they will be provided with a mask. Okay, so suppose I require 500 addresses. Now what will be the mask provided for me? How will you find it out? How many, what is the value of that mask? So you will be given /23. You will be given the mask value /23. What is the meaning of that? /23. I am told the total number of addresses, you can find it out from 2 power 32 minus n. Right? So if I am given the mask value as 23, 2 power 32 minus 23, you will be getting it as 2 power 9. Now what is 2 power 9? 2 power 9 is nothing but 512. Okay, so if I need 500 address or 300 IP address, I am provided with a mask value 23. Right? Understood how I am, what value of mask I am being provided. So you should identify. I told the range. First address, how you will be finding out. Last address, I will be finding out. And what is the total number of addresses. So now I require the total number of addresses is 300 or 500. Now what is the mask value I obtain? So mask value, it will be /23. So /23, the meaning is the total number of addresses, I have to count it out. So 2 power 9 is 512. So, and beyond that, 2 power 8 will be, you just calculate it. So if it is like that, it will be provided with /23. Now, if I want 1000 addresses, I will be provided with /22. Like that, it goes. Okay, so that is the importance of CIDR notation. If I need a block of address, I will be provided with the mask value based on that. Okay, understood what is classless addressing or classless routing? Yes or no? Classless, we were dealing with classless and classful addressing so far. Yes or no? Now, CIDR notation is nothing but it is actually the compact representation of the IP address. So classless addressing, you will have 4 bytes address and you will be defining the / value also, and that is nothing but it is a compact representation of the IP address. Okay. So just remember, these portions are very, very important: classful addressing and classless addressing. Now answer your attendance, Afla.
Present, Miss.
Ajmina.
Present, Miss.
Amaya.
Present, Miss.
Atulya.
Present, Miss.
Drishya.
Present, Miss.
Jyotish.
Present, Miss.
Karthik.
Present, Miss.
Kavya.
Present, Miss.
Nachiket.
Present, Miss.
Neeraj. Neeraj. Rangeet.
Present, Miss.
Vaishna.
Present, Miss.
Vaishnav.
Present, Miss.
Anjali.
Present, Miss.
Welcome back. Shruti.
Thank you.
Shruti, present. Neeraj is there.
Present, Miss.
Okay. So the PPT, I will be forwarding it today itself, and your series exam from tomorrow onwards, you will be having the series exam. So, and today, this is the last date for submitting your assignments, right? So by the specified time, before that, you all submit that. And second, third, and fourth, 10 to 11, you will have a unit test, because fifth, you will be having computer communication exam, no? So it is better that you study ahead and prepare it. So based on the time specified in that assignment 22, you have to comment. First, you will come to the Google Meet. Then after that, I will just tell you what you have to do it. Now, series exam, you have to make use of, legible handwriting is required. You have to make use of black pen and see how many questions are there. So regarding computer communication, you will have 3 parts: part A, part B, and part C. Part A, you have to answer 3 questions will be given, 2 you have to answer. That will be from module 1. And part B, you will have 3 questions from module 2, 2 you have to answer. Now part C, it is compulsory question. 1 will be from module 1 and 1 will be from module 2. So see the question paper properly and answer it. Whichever you are feeling it to write it in an easy manner, attempt that question and write it. Okay, based on, look on to the marks, how much it is being provided, and based on that, you have to answer it. Figure representation is very, very important, and you have only 1.5 hours, and you don't think that figure is very, very important, means like drawing it very neatly, that it will take time. Okay, so split the time according to that and answer the questions. Okay, right? So now we are going with the new IP address version, that is IPv6. So very, very important, all these topics. Again, I am telling the summary of that. Started with network layer, that is the 3rd layer of the internet model. And what is the important responsibility of network layer is to carry packet from the source computer to the destination computer. And if you many devices will be connected, and if you want to identify a particular device, you require the IP address. The first version was IPv4, and it was 32-bit long. So that 32 bits, you can represent it 2 ways, one in binary form and another one is in the dotted decimal form. Now that 32 bits The total number of addresses available in that was 2 power 32. Right? Now, after that, you have studied the concept of classes. This concept of classes means that 32 bits, like, you will be able to identify it to which class each address belongs. So class A, this many fixed size is given for you. Class B, this many. So then you have to remember what is the range, the decimal range or the binary range of each class. Okay, that is very, very important. And also after that, you have seen the importance of blocks. How many blocks each class consists of? What is the total number of addresses available in each class? Now, what is the drawback in that? Right? What is the drawback in class A, class B, and class C? So in order to overcome that, you use the concept of supernetting and subnetting. Supernetting, it is many small blocks combined and make it as a large block. So that is especially done for class C. Class C, many 256 addresses are only provided. So all these different blocks, they are combining and making it into a larger block. And then I told the subnetting concept. Subnetting concept means division of a large network into a smaller networks. Now, what is this important is the host. What is its meaning is the hosts are grouped there. I have told one analogy also. What is the meaning of that? Now, if so, you will have. So, if I want to deliver a packet, first I will reach the site or using the network address. Now, after that, I will identify where the host belongs, whether any subnetwork is there. So, based on that, I will be routing the packets. Okay, and I have told if you want to identify the subnet address, you require mask. So two types of mask, one is default mask and the other one is the subnet mask. So with that, with the help of that, you will be able to identify the subnetwork address. And two levels of masking you have gone through. One is boundary level masking and the other one is the non-boundary level masking. What happens if the value is 0 and 255? What happens if it is between that range? How will you able to identify the subnetwork address? So these are the things that you have learned in the previous classes. Okay. So that drawbacks, it was completely eliminated and that by the internet service providers when they became famous, and they have found out a new architecture, and that is called it as the classless addressing scheme. So in classless addressing scheme, what is told us, rather than a fixed size blocks, you have got a variable size blocks. So if a particular organization require only a small quantity of addresses and they are provided with a block. Okay, and also the subnetting concept can be involved in this classless addressing also. And that main idea of this classless routing or the classless addressing was based on the CIDR notation. That notation is x dot y dot z dot t slash n. That slash n is nothing but the masked value. So when you want this many addresses, you will be provided with the mask. So the total number of addresses that is available for you can be found out. Okay, so these were the things that we have learned up to now. Now the next concept, the next version of the IP address is IPv6, version 6. I have told when I taught IPv4, if you want to have little more flexibility, you require this IPv6 addresses. Now what is it? How many bits it has? It is 128 bits long. IPv6 address is 128-bit long. The meaning is how many bytes it has got. 128 bits means you have 16 bytes or 16 octets you have. Okay. Now I have told this IPv4, you can denote it in two ways. One is the binary and the other one is the dotted decimal notation. But when we are considering this IPv6, you can denote it in hexadecimal colon notation. IPv6 addresses can be denoted in two ways. One is binary and the other one is hexadecimal colon notation. Now, what is happening in this notation? In this notation, the total 128-bit is divided into 8 sections. You can just see in the diagram how they are being divided. Now, each section will be of 2 bytes. Okay, so hexadecimal, how many bits you are making use of to represent a hexadecimal number? Neeraj, how many bits? How will you convert a binary to hexa? What is the, how will you find the hexadecimal equivalent? Neeraj is there. Neeraj. Or Shruti. Yeah, Neeraj, tell. How will you convert a binary number to a hexadecimal number?
Group.
Yeah, you have to make a group of 4. So if it is like that, how many hexadecimal digits will be there in this? You will have 32 hex digits. If you have 128 bits, that is nothing but it is 16 bytes. So 1 byte is 8-bit long. So that 8-bit, you can group it into 2 hex digits. So the total hex digit, what is there is 32 hex digits. Okay, so the address consists of 32 hexadecimal digit with every 4 digit separated by a colon. That is the thing that you can see it in the slide. You have 128 bits or the 32 hex digits and you are, so the 4 digits after 4 hex digits, you are putting a colon and separating. Okay, so this is the representation of this IPv6 addresses. Now, it can more abbreviate like this. Abbreviated IPv6 addresses. So the original address, what I had is on the top, which is shown in the yellow color. The abbreviated one is shown in blue color and more abbreviated one is shown in the pink color. So what is the difference? Now, original, you can have many zeros in the middle. Okay, so what I will do is I will be making use of only 1 bit to represent that zeros. That is the abbreviated. The first hex digits are FDEC colon, then 74. That zeros and all I will just eliminate. 74, then 0, 0, 0, B0FF, 0 and FFF 0. Now again I can abbreviate in a one more manner, that is the more abbreviated value, and that is being shown it in the pink color. Now, in the next 5th hour, I will be just telling how you will be able to notate it like that, the more abbreviated form. If you have given an address, how will you represent it in hexadecimal form, hexadecimal notation form? Okay, so IPv6 is 128 bits. 128 bits means 16 bytes. That is 128 bit is divided it into 8 sections. So each section is nothing but 2 bytes. Now that 2 bytes is nothing but 4 hex digits, right? So totally the total number of hex digits will be 32. Okay, now you have to put a colon separating each 4 digit. And you can represent it in abbreviated as well as in more abbreviated form when you are considering this IPv6 addresses. Okay, so I will stop it here. Next hour, that is the 5th hour, I will continue with this IPv6 addresses. Okay. Assignments ellarum ezhudu kayinyo?
Sir.
Submitted. Etra per submit chedu? How many of you have submitted? Rangeetake ezhudu kayinyo? Shruti?
അമ്മ ചെയ്ത് കഴിഞ്ഞില്ല.
Make it fast. Today is the last date, no?
കുറച്ച് 2 ക്വസ്റ്റ്യൻ കൂടി ഉണ്ട്.
അതിനാ നിങ്ങൾക്ക് ഞാനൊരു 1 week ഗ്യാപ്പ് തന്നത്, ഓരോ ക്വസ്റ്റ്യനും ഓരോ ദിവസം എഴുതാൻ വേണ്ടി. So complete it soon and submit it. Okay. Now thank you. We will just meet in the next hour.